Let's see. I'm a senior project manager at Seagate. Currently working on the Hadoop on Lustre project. We've been working on this this year and just released. We made the announcement just yesterday that this is a product that's going to market. So I'm here to talk to you about Hadoop and Lustre. How many of you use Lustre in your environment right now? And how many of you use Hadoop? And how many people copy data into HDFS at this point? Yes, exactly. Do you tend to copy from Hadoop to, or from Lustre to Hadoop, or from other enterprise data warehouses? Okay. All right. Well, typically what I found is that a lot of HPC sites, and typically groups that use Lustre or high performance computing sites, are using Hadoop these days to do data analysis. IDC put out a report in 2013 basically saying that about 60% of HPC sites are using Hadoop for data analysis. They like it as a data framework for simplifying the way that they do data analysis, and as part of serial workflows to do different kinds of analysis, maybe doing some filtering of data, data selection, and then going on and doing numerical analysis and other kinds of modeling tools. And it looks like about 30% of compute cycles in those sites are being spent on doing Hadoop type of workloads. The kind of use cases where those workloads are being used are fraud and error detection, national security type of scenarios, finding the bad guys on Facebook, if you will, customer acquisition, smart electrical grids, social networks, as well as genomics and things of that nature. Now, who here likes to wait for stuff? Me neither. But if you're forced to copy data into HDFS, you tend to be waiting for a long time, especially if you have a lot of data to move. If you already have a Lustre-based solution in your environment, such as Cluster Store, you don't have to wait as long. We did some benchmarking of how long does it take to move data in and out of HDFS. And we found that compared to our Cluster Store solution, the performance of HDFS solutions is fairly poor. You'll see that the blue bars on this are copying data into HDFS compared with copying data into our Cluster Store solution. And you can see that as your file size increases, the performance benefits of using Lustre or Cluster Store in our case solutions increases. This is for Hadoop 1.0 and this is for Hadoop 2.0 essentially. Now, do you want to go faster? As I know that I do. So we developed a solution to help people like us who have Cluster Store solutions go faster in terms of doing Hadoop. And we've basically eliminated the task of copying data from Hadoop or from a Lustre solution or any kind of enterprise data warehouse into HDFS. So our solution is you put the data on Lustre or on our Cluster Store solution, and you can now use it directly without having to copy your data into HDFS at all. We've developed a what we call a Hadoop to Lustre connector. And as part of our Hadoop Workflow Accelerator solution, you're now able to use Hadoop, the data directly into Hadoop without any import into HDFS. Now the solution works by using a Lustre client and some proprietary configuration code to allow Hadoop to talk to Lustre, but we don't do any kind of code modification, any source code modification. We use Hadoop out of the box. We support Apache Hadoop and other popular distributions of Hadoop. Another nice thing about our solution is that we require no data migration. If you have an existing Hadoop cluster and you already have data there, you don't have to move it to Cluster Store. You can use it right out of the box where it is living right now and continue to use it or do your input from HDFS and your output to Lustre or vice versa if that's what you like to do. Or if you prefer, you can do all of your I/O from Lustre, which would give you the best performance. What the Hadoop Workflow Accelerator does is it eliminates the need to copy data into HDFS And plus our optimization settings lets you get higher performance from Hadoop than you would normally get from an HDFS solution. Now you would think that moving data over the network would take much longer than reading data off direct attached storage. But as it turns out, that if you have a high-speed network such as 40 gig Ethernet or InfiniBand, you actually get better performance from a parallel file system such as Lustre than you do from direct attached storage. And I'll get into some of those benchmarks. We found that for our ClusterStor solution, you can get up to 63% faster end-to-end workflow performance if you include the time that it takes to import your data into HDFS than you would if you had hosted your data on Lustre to begin with and just read it directly. But if you think, well, yeah, but you're counting the time it takes to copy the data in. Well, our performance, just for the analysis part, reading directly off of Lustre, is 38% faster than direct attached storage for Hadoop 1, and at least 28% faster than direct attached storage for Hadoop 2. And if you include the time that you have to wait for your data to be copied into HDFS, you could be between 63% and 53% faster than you are today. What this truly translates to is that you can run twice as many jobs in the same amount of time than you did before. Do I have any questions right now?
Does this depend at all on how the data is laid out on the ClusterStor system, or what kind of configuration system?
No, this could be randomly distributed files. One of the nice things. Okay. The question was, does it depend on the file distribution of the files? And no, we ran these benchmarks on TeraSort with random distributions of data. So there's no in and out. Let me show you some of our benchmarks. And these are actually TeraSort results, by the way. So we did a whole ecosystem, a set of ecosystem tests. We ran Mahout, Sort, word count, Hive, TeraSort, Pig. So we ran all these benchmarks and found consistently that our solution performed better overall. And this is just analysis. This is not counting any kind of data transfer time at all. Outperformed the direct attached storage solution. And these benchmarks were done on the same hardware. These were not two different systems. What we did is we had an existing Hadoop cluster with direct attached storage that we'd bought for another project. And we basically installed our solution, our Hadoop Workflow Accelerator on that solution, and using a high-speed network, a 40 gig Ethernet network, connected our ClusterStor system to that box. And we ran basically the same test on the same hardware using the direct attached storage of that box, and then the same test again, getting the data off of ClusterStor, essentially. And so this is an apples-to-apples comparison of both solutions. Any questions?
It doesn't depend on the format of the data.
No, actually we have a demonstration over here on the right that shows different kinds of tests, including random distribution of data and all that. We have a live demo of the solution right here. We have our compute, which is using 2U quad node servers, and a CS9000 scalable storage unit system right here, which is showing off our ClusterStor 9000 system. So you can come over here after the talk and ask questions and see a live demo of the product in action. So no, it does not depend on the distribution of data. Again, it could be randomly sorted. One of the nice things about Lustre and the fact that it's a parallel file system is that you can read from all the drives at the same time, essentially. And as you scale nodes, you get, especially for ClusterStor, you get scalable performance. So let's say you start with one SSU right here. You got 9 gigabytes of per second of I/O throughput. If you add another one, you get 18 gigabits or gigabytes of performance per second, and scale on, so on and so forth. So the other benefit is that, as I'm talking about this, is that you're now able to scale your compute and your storage independently. In a typical Hadoop installation, you have your direct attached storage. If you need to add more performance, you add another node with more storage, with more compute. You want to do it again, you have to do the same thing. You keep adding more storage that you don't really need. What this allows you to do is allows you to grow your compute independently as you need more performance, and you can grow your storage independently if you need more storage, depending on your data sets. let's see. In terms of relative performance, so this might be easier to see the differences in terms of performances. So this is an interesting thing. So for in most cases, Hadoop 1, oddly enough, whoa, why did it jump forward? Hadoop 1 is typically faster than Hadoop 2 overall. And we also found that that was the case for our testing as well. But you can see that we get 38 to 20% faster for TeraSort and for other benchmark tests as well. Let's see. Other advantages, again, I talked about being able to disaggregate your storage from your compute. That leads to benefits in terms of cost savings. So a typical Hadoop HDFS implementation requires you to do triple replication of all your data files, essentially tripling the amount of storage you need, the amount of usable storage that you need, or raw storage that you need for your data requirements. By switching to a RAID or a Lustre-based solution, you now pretty much half that. You only need about 20% more storage for redundancy and safety than you do for your raw storage needs. So that results in reduced storage cost, reduced server cost, as well as reduced space costs. Our cluster store SSU for the 9000 is a 5U84 drive. It's one of the densest Lustre-based systems out there, and basically allows you to turn, for example, a 2-rack or a 3-rack Hadoop solution into a 2-rack Hadoop solution in terms of the amount of storage and power and usage that you get out of the system. And typically will result in about 10% savings from a traditional Hadoop implementation in terms of total cost of ownership. If I'm going too fast, let me know, because I don't want you to wait, but I don't want to go too fast. Any questions so far? Nope. Okay, so why would you want to use the Hadoop Workflow Accelerator on ClusterStor? Well, like I said at the very beginning, you eliminate having to stage data to HDFS. Everybody that I talk to who uses Lustre or who and stores their data there and then has to copy the data into HDFS, is tearing their hair out, especially if they have large file systems or large file data sets. And as I showed in the first few slides, the larger your file size, the more you have to wait for HDFS to copy that data, not just to the first drive, but to all 3 drives where it has to distribute the data. So by setting that data in Lustre, you eliminate that wait time, and you also get faster performance from the parallel file system. Reducing the total number of data copies, you're only copying, you're using RAID, so you're not doing triple replication. Lustre is a POSIX compliant file system, so you don't have to do any special kind of scripting to make it work like you do with HDFS. Let's see. You leverage our high performance cluster store system, which scales, as I mentioned. If you need more performance, let's see, I think our largest implementation right now is able to provide over 1 terabyte of disk I/O, gigabytes per second. So you can scale this almost infinitely. So it's a very scalable storage solution. So we also provide enterprise class storage management. And as I said before, you can leverage the infrastructure that you've invested in. If you've already invested in HPC infrastructure like high-speed networks, high-speed, high-performance compute, and high-performance storage, you can leverage that investment to get faster performance and faster time to results than you do using traditional Hadoop HDFS-based systems. Now, another nice feature that I didn't talk about is that if you like, you can configure the Hadoop Workflow Accelerator to use only Lustre or ClusterStor for your Hadoop file access. The way the default configuration for Hadoop is with this connector is to do the import from Lustre and then the export the final output essentially to Lustre as well. And the intermediate files that each compute node does are on local drive. Those are typically small files, so you don't need a very big drive. But if you want to go completely diskless on your compute, you can configure it to do only Lustre-based storage and go completely diskless. and that will increase the reliability of your compute, essentially. Any questions?
Which environment were you in? Still local disk?
Yeah, it's exactly the same. So the question was, were my test results done on the same environment? And yeah, so all of our testing was done, again, using the same Hadoop cluster. It was a 2-rack. I think it was, how many nodes were in our Hadoop cluster? How many nodes were in our Hadoop cluster?
Over here?
Yeah, oh, no, over there in Longmont.
20.
It was about 20 Hadoop nodes that we were testing on. Each one had about 12 drives in it. Let's see. Yeah, like I said before, it was the very same hardware. All we did was add our connector in and did our Hadoop workflow accelerator optimizations to the box. And really without changing any configuration. So the same optimizations that we added to Hadoop to make it work with Cluster Store, we ran the same exact. We didn't change anything to make it better. The computer had the storage for the Hadoop on HDFS ties. So it was direct attached storage on the compute. But for the cluster side, or the Cluster Store results, those were over a 40 gig Ethernet connection. Totally disconnected. Yes. Any other questions? No. Well, why wait? If you're interested in the solution, you can call us at Seagate, and we'll get you hooked up. That's all I got.